This conference is brought to you by CallStack, a total software engineering consultancy.
Hey everyone. Thank you, Mo, for the introduction. I'm so excited to be here again. I was here 2 years ago, actually, on the fully remote event. So I'm really excited to see all the familiar faces again. The people you normally only see as profile pictures. So let's give a round of applause to the CallStack team for organizing all of this. OK, so maybe a little bit about me. I'm Marc Rousavy. I built a few open source repos. I built VisionCamera, I built react-native-mmkv, a bunch of other repos you might have seen before. And I'm running this development agency called Margelo. We focus on performance and all these other kinds of niche things like 3D and graphics. And today, I'm going to combine a few of those topics because we're going to draw onto the camera. Why do we want to draw onto the camera? What can we draw? What's the use cases, right? Why draw? So there's many reasons. Maybe we want to draw some, real-time. Can you see that? Yeah, some real-time, overlays. Maybe you want to show where a banana is on screen. Maybe you don't see it yourself. Maybe you want to draw some effects. In this case, a blur effect or a color filter. This one doesn't look as beautiful, but it works. Or some real-time face blurring in this case, like Snapchat or Instagram, to display something over the face. Or one example I'm really excited to show is something we built for a client at Margelo, where we use foreground segmentation. We remove the background, we dim the background here, and we create an animated GIF sticker of the hand or of the foreground that's showing in the video, all with real-time feedback, and then the captured video will only contain the foreground. Okay, so traditionally you would build two native apps because there's just no other way to do it in JavaScript or at least in React Native. So you would build one iOS app, one Android app, and it's hard to do that. A very simplified approach. You create an AV capture session on iOS. You create your outputs. You set up a metal rendering device queue. You set up the shaders. You render everything, and then you submit it to the GPU. You display it on the screen. You do a swap and everything. But then you still don't have stuff like buffer compression, pixel format optimization, all those kinds of things that you need to spend some time on to actually optimize the usage of the camera. And it's a lot. It's a lot of code. You need to write a lot. And the worst part is, it is a lot. And the worst part is you need to do the same thing for Android again. So you need to create a Java implementation. You need to use OpenGL, which sucks. And do the whole thing over, which is stupid, right? I mean, it's not stupid, but it can be better. So that's where React Native comes into play, and I'm sure we all use React Native because of this reason. We can write the code once. So in this case, we learn once, write anywhere. In the case of VisionCamera, we write it once and deploy it to iOS and Android. The key missing piece here is we need to do this fast. So performance is the primary concern here, because we're dealing with camera stuff, and camera stuff needs to be fast. I'm going to explain that in a second, why. But just real quick, VisionCamera. Who here has actually heard about VisionCamera before? OK, damn, quite a lot. Who here has actually used VisionCamera? OK, still quite a lot. Well, OK, I guess then I can finish the talk. Thank you, everyone. No, of course not. So VisionCamera is a React Native library to use the camera, to put it quite simply. And all of the complex concepts are abstracted away. So you have photo capture, video capture, snapshot capture, a QR code scanner. Then you have performance-specific concepts like buffer compression, pixel format selection, all those kinds of things that are very easy to use, I would say, and they're abstracted away. There's a lot of code on the native side. For example, this here is the start recording function, just to give an idea of how it works. On the left side, it's the iOS implementation of just the start recording function, and on the right side is how you would use it in VisionCamera in JavaScript. And this is the code base. So VisionCamera has a lot of Kotlin and Swift and C++ and Objective-C++ files, and on the right side you just see a simple example app which uses pretty much all of the features of VisionCamera, including code scanner, frame processors, photo, video, snapshot capture, device selection, FPS selection, HDR, all of those things. So it's not just less code, it's also easier to use. Today, we're focusing on frame processors. I did a talk on frame processors before, but a few things have changed since then. Frame processors have matured, and there's a new feature. So a frame processor is a function, to put it quite simply, a function that gets called on every camera frame. So it is kind of like an event. On every frame the camera sees, you get a callback. They are powered by worklets for the simple reason that a camera is running on a separate thread. We're not running on a normal UI thread or JavaScript thread. We are running on a separate thread, and we need to run something asynchronously, and our frame processing code needs to happen in parallel. We don't want to block user interaction. So yeah, they are running synchronously on a separate thread and fast. But they're still just callbacks. This is what a frame processor looks like. It is a function. You can do whatever you want in there, and then you receive a new frame on every camera frame. I'm going to explain the frame concept in a second, but you can just put any JavaScript code in there. It's inspired by Reanimated 2 with the worklets concept, so great idea here from the software mention team. And then you just, in this case, I just log the frames width and frames height. So yeah, and the rest is magic. So VisionCamera worries about setting up the whole device queue and rendering pipeline to make sure you don't need to do that. Yeah, this is what it looks like. So what's the frame? The frame is a native object. It is in C++ or in Java and Swift to be specific, but it is a native buffer which needs to be exposed to JavaScript somehow. It is on a 4K RGB frame. We have a 33 megabyte buffer. After just 1 second, if we stream at 60 FPS, we have 2 gigabytes of data flowing through our JavaScript function. A camera on an iPhone, on a modern iPhone, can run at 240 FPS. So that's, I think, 8 gigabytes per second. So you just need, I think, 2 minutes for a full terabyte of data flowing through your JavaScript function, which is backed by a GPU buffer. So it's GPU memory, but still a lot of data. So VisionCamera had to, so I had to send the frame to JavaScript, from native to JavaScript, fast. We can't just serialize it or convert it to a base 64 buffer. We needed a way to expose the C++ object directly by reference without doing a copy. So I know Svetan is sitting somewhere in the crowd, so please, now is the moment where you close your ears. The frame is a C++ host object. It is not yet a native state. With Nitro modules, this is going to change. This will be a native state then. But for now, it is a host object, which is still very fast. Who here knows what JSI is? I think everybody does, right? OK, a few people don't know it. So JSI is a layer between C++ and JavaScript. You can write some C++ code and call it from JavaScript, and you can write some JavaScript code and call it from C++. Pretty simple. And then there's the concept of JSI host objects, which are C++ objects. They're kind of like a proxy, like a JavaScript proxy, but they're implemented in C++. So you can actually call, or you can actually have an instance, a native instance, a C++ instance, be exposed to JavaScript. I'm not going too much into detail here because this is a, like there's a lot of talks that talk about JSI. But yeah, just for a basic understanding. So for example, the frame in a frame processor exposes a few properties. We can see bytes per row, height is mirrored, all those kinds of properties, orientation. and a method to array buffer, so we can actually get an array buffer from the frame. This is all fully implemented in C++. So there's no JavaScript layer in the frame. The frame is a C++ instance. OK, so we have a basic understanding of how it works and what a frame processor is. How do we do the actual frame processing now? VisionCamera chooses a hybrid approach. So your app's business logic is in JavaScript. This includes camera setup code. So that's deciding, front camera, back camera, FPS, blah, blah, blah. The actual high-performance processing part is in native code. So that's, GPU-powered native stuff. We have a lot of flexibility because we can write JavaScript, and we're still very fast where it matters, which is in a native processing code. So what exactly is the native processing code? First of all, VisionCamera's core code base is fully native, obviously. So that's in the npm package that you install. And then every frame processor plugin can be in native code. So that's either in your app's code base, like how a native module can be in your code base, or as a separate npm package, already pre-published by someone else. Right, so this frame processor plugin I just mentioned is a simple native function that performs some sort of processing on a frame. So you receive a frame, you do some processing, you return data. It's very often just a simple Swift or Kotlin file, which just it's very simple and short in the implementation. And most of the time, it's just a wrapper for existing libraries like mmkv for face detection, object detection, or Apple Vision, or TF-Lite. All those kinds of processing libraries that we all know and love. Here's an example. This is a Swift frame processor plugin. I would say it's quite simple. You have an initializer, you have a callback function, receive a frame, run the face detector, and then return data to JavaScript. They are fast, because native languages are just faster than JavaScript, which might change with static Hermes. So I'm excited to use static Hermes in frame processor plugins as well. But yeah, you can use the GPU. You can benefit of all other kinds of, like lower allocation overhead, all other kinds of primitives in native languages to make sure the actual processing code is fast. So what's in JS now? Now that we know that processing code is in native, what is in JS? Well, firstly, your app's business logic is always in JS. You set up the camera, you decide what to do, or which FPS to choose, which resolution. Do we want 720p, 4K? We configure all of the plugins. So we maybe initialize the plugin. There was an init method before. And then we decide what to do with the result. So here's an example. We initialize a face detector plugin with the fast model. And we can use a state value to just switch to the accurate model whenever we want. Then we run it. And then we loop through each face and just log it to the console. Logging to the console won't really help the user a lot, so we need to, now we get to the interesting part, how can we actually draw? So do we set a state? Do we use a set state value? We can set a state, update the UI, and a view will, for example, for a bounding box in this case, will follow the face, for example, of the user. Probably not a good option. It's first of all, a separate thread. It's probably going to lag behind. Are we going to use a reanimated shared value? That's better because it's faster, but it's still, from the principle, not going to work because it's not the same thread. It's happening on a different thread. Reanimated runs on a UI thread. Our camera is on a camera thread, so it is going to lag behind by design. Yeah, drawing is not synchronous in these cases. We are on a separate thread. We're going to lag behind. It was limited to views, so we couldn't really do any like shaders or effects to resample the input image. And we're drawing above the camera view itself. So we're not drawing into the camera stream. We're putting views above the camera view. So this is what that looks like. Just took the picture in the hotel. We aren't, in the view case, we have a view on top of the camera view. It's not going to be part of the video recording. It's not in the camera stream. It is just a separate view. In this case, on the right side, we can see that I'm actually putting it into the camera stream. So how can we now draw freely? What's the solution? This is where Skia comes into play. Skia is a high-performance 2D graphics library. It's developed by Google, and the focus is on drawing and not rendering. So that's the key difference here. We can actually draw something. We don't need to render something. Where rendering is more focused on views, on UI stuff, and drawing is more like you give a child a crayon and he draws something. React-native Skia brings Skia to React Native. It's developed by Shopify, by the two amazing developers, Christian Falch and William Candion. And this is also the exciting part. This is how Skia looks like. So we create, for example, a rectangle, give its coordinates, set its color to red, boom, render it, or draw it. So this is the exciting part now. We can combine VisionCamera and Skia to use Skia for drawing in VisionCamera. That's a new VisionCamera V4 feature I introduced in, I don't know, maybe April. It's called Use Skia Frame Processor, and the difference is that it allows you to actually draw back to the frame, whereas a normal frame processor is just read-only under quotes. A Use Skia Frame Processor has two threads to manage. It's the camera thread, which is running at a different frequency, I would say, than the UI thread, because we might have, your camera can run at 30 FPS, 60 FPS, maybe even 240 FPS. There's a golf app which uses VisionCamera to analyze your golf swings in slow motion, so 240 FPS. Whereas your UI thread is running at a different frequency. So we only need to take the last result from the rendering and put it on the UI thread, whereas the rendering thread needs to happen more frequently. So again, a very important performance constraint. Here's a real-world example from an unknown person who has their face blurred, and we're going to build this in under 1 minute. I'm not going to do it live, so I just want to walk around here freely, but I'm going to show you how to do this. So there's 3 main steps to this. First, we need to do all of the initialization. We need to set up everything. We need to set up the camera, the face detector plugin, the Skia shaders or filters which we're going to use. Then we're doing the actual live detection. We're going to detect each face in a camera frame. And then we decide what to do with the results. In this case, we want to loop over the faces and draw a blur filter over each face. So that's the face detector plugin. We set it up, performance mode fast. It's a plugin on NPM. You don't need to do any native code. Just download the plugin. It's by a guy called Louis. He built this plugin, amazing plugin. And it just works with VisionCamera. Then you do the same thing for the Skia filter. You set it up. In this case, we use a blur radius of 25. It's just JavaScript code again. Blur filter, set it up, create a Skia paint. So here comes the real-time processing part. We use a Skia frame processor. We render the frame once, so we need to actually explicitly call render. So the frame is now on screen, right? We think of this like incrementally constructing the resulting image. So we have to frame once. Now there's still, the face is still on there of the unknown person. We detect all of the faces in the frame. This is the part that calls into the native plugin, into the Swift or Kotlin plugin. I think the library uses MLKit, so it's pretty fast. Then we iterate over each face. In this case, we probably only had one face on the screen. We construct a Skia path. We create a rectangle of the bounding box around the face. Then we create a clip path. So we say, OK, only render this section within this oval, this rectangle. And then we render the frame again with the blur filter paint. So normally, it would just render the whole thing blurred, but we only have the clip path of the face, and we only render that on top of the normal frame. And yeah, and that's really fast, and it works. And then the final result is, just an app with 40 lines of code. It's very flexible. We can tweak it on the fly. We can just change the blur radius from 25 to, 30 if it's not enough. Hit Command S, it saves, reloads, and boom. So That's something that's just, in terms of flexibility and development speed, unmatched so far. There's no other toolkit to build stuff like this so fast. All other changes, as I said before, the traditional approaches required you to do all of this natively, rebuild your app and everything. In this case, we can do everything with JavaScript. It's also fast. 10 milliseconds total execution time, including the face detection, the JSI part, and the drawing part. So it could run at 100 FPS on this specific phone, which is, I think, an iPhone 11. And the best part is it also runs on Android. Yeah, that's the cool part. We don't need to write Java or Kotlin. So yeah, it runs on Android. But I want to emphasize real quick, VisionCamera is still a camera library. It's not just about drawing blur filters. It's still a camera library. It's like a Swiss Army knife almost. You can still use custom device selection, ultra-wide-angle cameras, photo capture, 10-bit video HDR. That's also something pretty cool. And then I built an app called ShadowLens. Maybe you want to check this out. It's built with React Native, uses VisionCamera. A good demo app for showcasing the camera features of VisionCamera, I would say. The future of VisionCamera, so it's out there. VisionCamera is out there. It's released on NPM. It has 6 million downloads on NPM. It has 7,000 stars on GitHub, and it is used in many production apps today. Many of our clients use VisionCamera today, and it's working out great for them, apparently, because they didn't fire us yet. You can try VisionCamera today. It's all on GitHub. VisionCamera is on GitHub. react-native-Skia is on GitHub. And the face blur demo app is on GitHub as well. If you want to check that out, run it on your phone, test it on your phone, blur your faces for whatever reason. And yeah. So if you have any questions about VisionCamera, want to talk to me about VisionCamera or Nitro modules or anything else, I look like this. You can find me here. Or follow me on Twitter or my agency on Twitter and just reach out to me. And yeah, thank you, everyone.
Awesome work, Marc.